So yesterday we started with Numpy, and we saw that Numpy, yesterday we started with Numpy, and we saw that Numpy is a numerical computation library that we will use for mathematical operation. So most people use Numpy for linear algebra, especially when you're doing matrices and vectors. You can also use it for calculus operations. And you're going to see that these mathematical operations are essential for data science, machine learning, artificial intelligence, and so on and so forth. So I want us to continue. Here. Let's continue. I want us to continue. So today we will be talking about Pandas series and dataframe. That will be our main objective. But before I do that one, so that now we are at par together, let me just mention what we did yesterday on Numpy. So I'm just, the recording is already there in case you missed the class. And you can also attempt the quizzes that we have already uploaded for you. But I just wanted to do a quick recap on Python Numpy so that now we are effectively able to use Pandas. And because you're going to notice that the Pandas that you're supposed to learn today is built on top of Numpy. So something to remember yesterday is that Numpy is a very powerful Python library for numerical computation. And you're going to notice that Numpy is widely used in data science, machine learning, or in scientific computing. So you cannot do without it because it mainly supports what we call multi-dimension arrays. Okay? You can also use it for mathematical operations and linear algebra functions. And this will enable you to fast and efficiently process data compared to traditional lists. Okay? So that is very important, and that's the main reason why we were actually talking about Python Numpy. So, so to break it down, what we did yesterday. So yesterday, by the end of the class, I was hoping that now you understand what are Numpy arrays. How do you create them? So you saw that we can create a one-dimension array with just a sequence, a two-dimension array, which you say that when you have the rows and the column, and this is what we will be using anytime we want to represent data in tables. For example, in Excel, CSV, or SQL. And then later, this will be later in more advanced topic, we'll be talking about the three-dimension arrays, where we have the x-axis, y-axis, and the z-axis. That was very important. And by the end of that lesson, I was hoping you were able to create a Numpy array. You understand some of the properties of Numpy array. So just to remind you, we have the shape, which talks about the dimension of the array. So you can say 2 by 3 or 3 by 4, a Numpy array. So the dimension is the number of dimensions you have. You can have a one-dimension array, two-dimension array, three-dimension array, four-dimension array, and so on and so forth. The size talks about the total number of elements you have in your Numpy array, and the data type refers to the data type of the elements that is stored in your Numpy array. It's very important for you to know how to create this create Numpy array using built-in functions. So we saw that you can have zeros and one, you can have identity matrix, you can have random number generation, or you can also create Numpy array using the sequences, which we have the range and the line space. So definitely it was important for us to be able to index, which is mainly to get information from a Numpy array. This was very important. We saw that you can work with indexing, the one we did on Python list, you can work with negative indexing, or you can also perform what we call slicing when you want to extract a sub-array, okay? And then now we saw some of the mathematical operations that you can apply on a NumPy array. For example, you can apply the basic arithmetics. You can perform vectorized computation, or you can also perform statistical functions. For example, you can get the mean, median, standard deviation, variance, and so on and so forth. So, and then finally, yesterday we saw that with NumPy array, you're also able to reshape and transpose data in such a way that now you can rearrange or restructure the arrays without modifying the data that is present. So these are very important tools. I would really wish you can practice a lot on it. That's why I shared both of the notebooks. So this was our guide notebook that we were using, and this was our class practice. So if you want to see the class practices that we did, I've already shared the notebook as well. So now let's dive into our today's objective, which is Pandas. So today we want to talk about Pandas as an EDA tool that will help you to explore, analyze data. So I want us to start from there unless there is a question on NumPy. So I'm just confirming. So there's someone saying, I hope you are able to be, I hope, I don't know the name, Move J. I don't know whether you have been assisted. I hope everyone is okay. So we are ready to proceed with Pandas, which is our main objective today. So if no question, let's proceed to Pandas. Let's proceed to Pandas. So I want us to open, I think you can collapse this one. Then we start on Pandas. So it's a 30-minute session. Then we're going to have a Q&A session. And then we do some class practices. So today we want to do Pandas by specifically talking about Pandas series and Pandas data frames. So I'm very confident that if you're able to understand, differentiate between a Pandas series and a Pandas data frame, then I'm sure you are ready to now start your data analysis with Python. So as usual, I want us to set up our environment. Let's set up our environment by actually clicking on this one. Now, if you just click on it, it will open on a new tab, like that one. So we want to use this one. We want to use this one for our guide, as our guide notebook. I hope this notebook will help us clearly understand what is Pandas and where we can use it. From there, I also want you to open your own class practice. So let's do that one. Because like we've been saying, tech skills, you can actually learn them better by doing your practices. So for our class practice today, just open a new Google Colab. Just open a new Google Colab. Sorry for that one. Sorry for that one. We were actually creating the environment where you create your class practice notebook here. So this is your class practice notebook. Definitely, this should be your guide notebook. This should be your guide notebook where you want to do the class practices on Pandas. And then you want to start by now going through these notes. So in summary, this will be our lesson objective. So by the end of this lesson today, my hope is that you will be able to understand Pandas series and data frames. That is the main objective today, okay? At least you should be able to understand what are Pandas series and Pandas data frame, because you're going to see that they are the key data structures that are mainly used in data science and data analytics. So from there, you're also able to perform some basic and advanced operation on Pandas. So you're able to, let's say you're able to fetch data, you're able to filter information from Pandas series or Pandas data frame. Later also, our objective is also that you're able to load, clean, and analyze a real-world data set. So for this one, we just want to use some scenarios whereby we'll be demonstrating how you can load, how you can clean, and how you can analyze a real-world data set before analysis. Okay. Then later, we are also hoping that you're able to sort, you're also able to filter, and you're also able to apply statistical functions on data that is stored in a Pandas series or a Pandas data frame. This will be a later objective, but we just mentioned it. It will be how do you work with a grouped or a time series data. So a time series data is a data that has been related with time. Let's say you want to get trend analysis. So these are our main objectives today. So to start us off, before actually understanding what are Pandas series and what are Pandas data frame, let's first understand what is Pandas. What is Pandas? So what is Pandas? So you're going to see that Pandas is an open source Python library. This means that this library is freely available. It is freely available, and it is designed for data manipulation, data analysis, and data cleaning. Therefore, it will be providing us with fast, flexible, and powerful tools for handling structured data that we're going to mention later. Structured data that are stored in tables like in spreadsheets and databases. So by you mastering Pandas, it will be my hope that now you'll be able to manipulate data, analyze data, and clean it, because you'll be actually working in very fast, flexible, and powerful tools for those procedures. Why is it important? You're going to see that Pandas can handle large data sets out there. Pandas can support data from different formats. So you can actually handle data in a CSV format. You can actually handle data from an Excel format, JSON format, or SQL format. Okay? So Pandas can allow you to clean data. For example, it can allow you to handle missing values. It can allow you to remove duplicate records from your data set. So Pandas is also able to sort, filter, and perform aggregation function like sum, average, and so on and so forth. So you're going to see that later you can actually integrate Pandas with other libraries like Matplotlib, Seaborn, and Numpy for more advanced data visualization. Okay? So that is actually why Pandas is so very important for data scientists or data analysts. So now I want to start today by now. Let's start by now exploring now what is a Pandas series. So other people refer to it as a one-dimension data structure. Okay? So a Pandas series is a one-dimension label array that you can use to hold integers. So remember we said integers and numerical digits without decimal points. We also have floats. We also have strings. So Pandas is useful for time series data. It is useful for stock prices or any single data variable. Okay, so just something to remember is that a Pandas series is a one-dimension labeled array. So these are the key features of Pandas series. So for you to work effectively with a Pandas series, then it works like a dictionary. So remember we talked about dictionary, where each value has a labeled index. So each value that you store in a dictionary is having a labeled index. So that is one feature about Pandas. Another feature is that Pandas supports mathematical operations like finding the maximum, finding the minimum, finding the average values. And also you can use Pandas to filter specific values based on conditions. So these are the notes on Pandas series, so you can use it for indexing, where each series has an associated index. It can be numeric or a custom label. This is something you're going to see. So in terms of data types, a series can hold integers, floats, strings, or even Python objects like you'll be seeing later. You can perform some operations like addition, subtraction on a Pandas series. You can actually use filtering whenever you want to get a specific information from a Pandas series. And later you're going to see that with a Pandas series, you can actually handle missing values, which will be calling them not a number, none. We'll be calling them that one. So the real world use of a Pandas series will be in stock market analysis and temperature monitoring. So later, after understanding Pandas series, so remember Pandas series is a one-dimension label array. That's something you're going to demonstrate. Now, going to Pandas data frame. Now, this is actually a two-dimension data structure. So to understand Pandas data frame is that a Pandas data frame is a two-dimension table that is similar to an Excel spreadsheet. So it consists of rows and columns, where each column is referred to as a series. That is something I'm going to demonstrate. So these are the key features of a Pandas data frame. So you can actually sort, filter, and group information. You can actually merge, you can reshape, you can aggregate data set in a Pandas data frame. And also, Pandas data frame can handle large data set efficiently. So these are the real world use of a Pandas data frame. You can use a Pandas data frame to even analyze HR data, okay? So from understanding Pandas data frame, we're also later going to see how to clean and preprocess your data. So if you're cleaning your data, possibly you are handling the missing values, you are removing the duplicates, you are changing the data types from one point to another, or you actually, in real world use is when you're actually cleaning a messy data. So that is actually fourth application of Pandas. The fifth application of Pandas is that you can use it for sorting and aggregation. Yeah, sorry for that one. So you're going to see that you can use Pandas for sorting and aggregating your data. Also later, you're going to see that now we'll be using Pandas for some advanced analysis, like you can use Pandas for climate change analysis. You can use Pandas to analyze sales data, or you can also use Pandas to analyze healthcare data. So in summary, now today's class, we'll mention about Pandas series as a one-dimension labeled data. We are also going to mention about Pandas data frame as a two-dimension table for structured data. So it's a 2D where we have rows and columns. We'll be talking about data cleaning. We'll be talking about data sorting and filtering. And finally, we'll be talking about data aggregation and grouping. So just to make everything now clear, let's open this notebook that I've actually shared here. Make sure you open this one so that now we can clearly understand all these components. So make sure you have this one here, and you have your class practices here. So I want to put it here, that one. So this is actually our guide notebook, and this is our class practice. I wish to share this one in case you're not able to access the classroom. So I'm sharing this one on the chat. That one. I'll share that one on the chat. In case you're not able to understand, in case you're not able to get the link. Okay, so let's start by now doing some class practices on Pandas. So these are the notes that we've been going through. So you've seen that Pandas, it's a library for data manipulation, data analysis, and data cleaning. So it will be providing you the tools for handling structured data. So I want you to imagine if you have ever used an Excel file, if you have worked with a Google Sheet, or you've worked with an SQL data set, SQL databases, then Pandas will give you more controls or automation over this kind of data. So because it has it is actually built on top of Numpy, making it efficient for numerical computation. So I've mentioned about why it's important. You can use it for loading data. You can use it for cleaning data. You can use it for filtering and sorting data. You can use it for performing statistical analysis. And also you can use it for data visualization. So if you're learning Pandas, I want you to think of it as a superpower Excel, but it's built on Python, making it more flexible and scalable. So if you're thinking about Pandas, then think about it as an Excel file that is built with Python with more flexible and scalable tools for analysis. So starting with Pandas series, so this is now we want us to be very keen. So Pandas series, we're being told, is a single column of data. So we're being told that a Pandas series is like a one-dimensional labeled list. So it is useful when working with a single variable. For example, you can record your temperatures, you can record your stock prices, you can record your sales in a Pandas series. So let me give you a good example. Let's say you want to record your daily stock prices from Monday to Sunday. Let's start from there. So let's go to our class practices here. And then today we are actually learning about Pandas as an efficient Python tool, for loading, for cleaning, sorting, and filtering. Structured, so you realize you've been calling them structured data. So structured data is a data that has been represented in table. So for example, you can have spreadsheets. We can also have SQL data and so on and so forth. So that is why we are learning Pandas, because it will be a very efficient tool for us to clean, to load, clean, to sort, to filter information that is stored in a structured data. So structured data are information that is stored in table format. We normally call them tabular data. So a good example is those spreadsheets that you have or SQL data that you deal with every single day. Okay? So we've seen that Pandas is very efficient because it has two data structures. It has two data structures. That is why it's very, very efficient. So the first data structure that you'll meet in Pandas, number one, is what we'll be calling a Pandas series. And you're going to see that a Pandas series is a data that is represented in a single column data. So you can just call it a single column data. A single column data. So in more advanced detail, you can say this is actually a one-dimensional data. A one-dimension data. So that is very important to note. And also, if you're learning Pandas, then you're also going to meet number two, what we'll be calling Pandas. Pandas data frames. And you're going to see that this is now represented as a multi-column data. So it's a data that is filled with many columns. So a multi-column data. So in mathematics, we'll be calling it a two-dimension data. That means that the data will be represented with rows and columns. And that will actually be now representing data that you store in a table. So if you have a table, then you have the rows and the columns. And to represent this data in a table, we'll be using Pandas data frame. So anything. Okay, so you want to start with Pandas series. Let's start with Pandas series. Pandas series. So it's only when you want to record your information in one variable, in one variable. Whenever you want to record your information in one variable, for example, I want us to begin here now. I think I can share this one first so that we have an highlight of what we are doing. Share this one with you. Okay, so that is actually some highlights about the pandas that we'll be talking about. So let's start with now pandas series. So pandas series. Okay, so pandas series will be data that is represented in one column. So let me give you an example. Okay, so let me give you an example of a pandas series. So let me try it in this manner. Let me try it in this manner. So I'll start by saying that I have my stock prices. So for 7 days, I have my stock prices for 7 days. So let me first represent it in a list format. So then definitely I would copy this one here. That one. So for 7 days period, this has been my stock prices. So I have 180, 185, 90. So this was Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Okay. So if you want to represent this data in a pandas series, then first you'll have to import here pandas as PD. So PD will be actually the alias name to represent pandas. So then now we can say that here, stock prices in the pandas series will be, I want to assign that one. So you have an equal sign. So you just have to say, using the pandas, there is a class called series. Okay, like that one here. And this class, that's why it's in capital. As you can see, the series is in capital because this is actually a class. It's not a function, it's a class. So then you will assign your stock prices as a list. So you can copy this one and paste it here. That one. So now from there, you can actually now read your stock prices. So you don't have to print. You just have to place your variable here, and then it will display the information in a notebook. Let's run this one, and then you confirm whether you're seeing what I'm getting. So then I'll share this one with you. You can also try out this one first. So sharing this one here. So I hope you can see that this is what we call a pandas series. A pandas series. A pandas series. So a pandas series is basically data that is represented in a single column. Okay? And now by default, let's even say here, by default, each data is assigned an index number starting from 0. So by default, that is what you are seeing. Okay. So you can actually modify the index number to be of any index that you wish to have. So by default, the indexing are actually starting from 0 all the way to 6. So these are the indexing by default. And then also the column name is an index. I want us to see that one. So also this column name here, it's called index 0 column. Okay, index 0 column. So you can actually modify this information here. You can actually modify this information here. So I want us to see this one. So you can actually say that the columns is equal to, then you put the list of columns you want, because at some point there will be many, so you can actually put out. For now, you can just say the name for now, because it's a series, and just say the name is, I want us to see what happens. The name is stock prices. Stock prices. So I want us to see that by default, the column name was assigned 0. That is by default. Okay, but now if you modify the name, then now this 0 will be replaced by the name of the column that you assigned here. So let me run this one again and see what happens. Now we can see that now I have modified the 0 to be represented as the stock prices. Okay, this is the column name. So alternatively, you can also modify the indexing to be of any data type. For example, I can now say index can be a list of index, like that one. Okay, can be a list of index starting from Monday. So the index that you put should be exactly the same as the number of indexes that you have. So this one we have 7, so you should be having the 7 days here. So the first one is Monday. I can also represent Tuesday. I can also represent Wednesday. Then I should be going to Thursday. I should be going to Friday. I should be moving to Saturday. And then finally, I should be moving to Sunday. If I run this one here, you're going to notice that I have modified the column name, and I have also modified the indexes of my Pandas series. So I want you to see this one, and this will be effective now anytime you want to create data that is represented in a table format. So I'm sharing this one with you here. This is very important. And I hope you can see that one there. I hope you can see that one. So in this Panda series, we have the stock prices, we have the name. So you're going to see that at some point, you can actually represent this one in a variable. So you can actually represent this one in a variable. You can actually say, so to make it simple, because it's very long, you can actually remove it here and represent it in a variable here. So you can say days are these ones. So now you can say that the index can be represented as these days here. So you can actually say days, that one. So if you run it, you should be getting the same output here. So you can say these are the stock prices. They will be displayed here. The name for those stock prices is this one here, which by default was 0. And then the index, which by default was starting from 0 to the last one, can actually replace them by a list of indexes that you want to pass. Okay, so it will give you an error if you have 7 indexes and you're providing 6. If I remove this one, this should be an error. I hope you can see. And you'll be told that the length of the values are 7, but you're providing the index that is matching 6. So that is an issue. That's the 7th one. That's why if you have 7 items, then your index should be represented by 7 items. So let me share this one again with you here. Let me share this one with you here. You're missing anything? You can always ask. You can always ask.
After wame wamefanya exam. Ndio hapa.
Okay, so I want you to see how Pandas series works. So Pandas series is basically data that is represented in a single column. So if you have this data represented in a single column, then the single column can have a name. So you provide the name here. Similarly, the single column can have the index. So by default, if you don't provide the index, it will assign you index 0, 1, all the way to the last index. So that one really makes sense. If you have a question, you can definitely ask. So these are one-dimension data. So the one-dimension data is this stock prices. For this dimension, you can actually have the name and you can have the index. So let me proceed from there. No question is available. And this will be very, very useful and effective, especially now when you'll be doing data mining, data cleaning, and so on and so forth. That's why you saw that. Alternatively, the easiest way you can even do it is this one here. So this is actually an alternative way you can do it. So if I copy this one here, let me just copy this one here. If I copy this one here, so this is an alternative way to do it. If you paste this line of code here, so I've imported Pandas as PD. So I want to create Pandas series. So the first thing I do is that I just call the pd.series, then I pass a list. So this is very similar to putting the list in a variable and passing it here. So it's very similar. So here they passed it directly, and the index, they have actually passed the index directly here. So if you print the stock prices again, you should also get the same thing here, okay? Yeah, the same thing here. So you have Monday, we sold 180. Tuesday, we sold 185. Wednesday, we sold 190, and so on and so forth. So for better view, I would always advise that you don't now need to print, just have to put your variable there, and you can now view it better this way. I hope you can see. So you don't have to print. You can just place your variable here and see your Pandas series here. So your Pandas series, I've said, it have the properties of, these are the values. These are the values. This is the name. This is the index, and this is the data type. So if you want to put the name for this column, then you can also add here the name. So I have these are the values. These are the values. These are the names. Okay. Put a comma. Those are the index, sorry. Then now the name, can now put it as, you can call it any name, for example, stock prices. So if you run this one, then now you get a complete Pandas series. So you have the values, the index, the name, and the data type. So let me move further. So before going to the common operation, it would be really important for me to mention properties of Pandas series. Properties of Pandas series. So in case you don't have a question, we can talk about here properties of Pandas series. So I think I should be sharing this one with you so that you can try out. So properties of Pandas series. Properties of Pandas series. So allow me to talk about properties. Properties of Pandas series. Just like yesterday, we saw that Numpy have their own properties. So we saw that Numpy have a property to do with, it was the size, the dimension, the data type, and the shape. So even Pandas series have their own property. So we have 4 properties in Pandas series. So the series have 4 properties. So I want you to be very keen here because this is actually where we'll be connecting Pandas and Numpy. So the first property, number 1, is the values. So the values are the information that is represented in a Numpy array. So the values of a Pandas series are represented in a Numpy array. I want you to see that one here. So these values here, these are the values. These are the values I'm talking about. They are represented in a Numpy array. So they have all the properties of a Numpy array. So you can get the shape, you can get the dimension, the size, and the data type. So this is what we call the values. So the values are what you put in this array. So apart from that one, number 2, we also have the index property. And we're going to see that the index is, it's actually how the information can be retrieved, how the information can be retrieved. But you're seeing that by default, index are numericals starting from 0. But this can be modified to custom index. So by default, if you don't specify the index, like I don't specify this index here by default, if I don't specify this index here, sorry, I cannot have it that way. So if you don't specify this index here, then it will actually pick the numerical value starting from 0. So if I were to remove this one, I think I will return it back. So if I were to remove the index out, then by default, the indexing will be actually how do you access these values. So if I want to access 180, that is at index 0. So this is actually a Numpy array. And you say that a Numpy array, you can actually access values based on index. So 185, you can access it at index 1, and so on and so forth. So this is also a property of a Pandas series. And you're seeing that this indexing can be customized by you adding your own index. So if you add your own index here, then you can actually customize the indexing here. So I hope you've noted that one. That is the next property. The third property of a Pandas series is the name. So the name will actually represent, it will represent the name of the column, the name of the single column. Let me just say the name of the column. So by default, if you don't specify the name, then the name will actually acquire an index that is 0 by default. So this is the name I'm talking about here. So if I don't mention this name in my Pandas series, just remove it, then it will acquire 0. I hope you can see that one. So if you add another column here, that will be 1, another column that will be 2 in that order. So if you want to now modify the name, you can actually add the name property right here, and then it will acquire that specific name right here. So if you run it, you get the name. And then the last property of a Pandas series, very important, is the data type, what we call the div type. So the data type, it represents the data types. So let me just say the data types of values stored in a Pandas series. So what I'm saying here is that if these are the values that you have in your Pandas series here, what is the data type for this value? So you can see that the data type that I've stored for this one is of int 64, integer 64-bit. And there's something I want to try out and confirm. In a Pandas series, you can only work with one data type. Let me say I make this one a string like that one. Then I think it has converted it direct to an integer, but now it's referred to it as an object because we have actually mixed the data type. So if you want to work with a specific data type, then you'll have to ensure that all the values you have are of the same, they are of the same data type. So they could be integers, they could be floats, they could be booleans, and so on and so forth. So I want to share these properties with you, and then we can try them out together here. So these are the properties of a Pandas series. So let's try them out here together. Let's try them out here together. So we can actually start with, let me first print. Yes, these are the properties I wanted to print. Let me first print. These stock prices. This stock prices is it's a Numpy, it's a Pandas series. So I want to print the values, I want to print the index, I want to print the name, and I want to print the data type. So if you print all these one, then you're getting that these values, it's an array of values. I hope you can see. These are values, represent the array of values. So we say that the values are the information that is represented in a Numpy array, and they're the one you're seeing here, the values here. If you're talking about the index, the next property here, then the index are the list of indexes for your array. By default, if you don't specify the index, then it will actually pick the numerical indexing by default. Then the name of your series is stock prices, and your data type of the value is integer 64. So there's something I wanted to try. What if I print here? What if I print the type, the data type of these values? Let me print the data type for these values in my Numpy array or in my series. So if I print the data type, then I'm told that these values that I've stored in my Numpy array, these values, they are now represented as a Numpy array. And this is actually how you can connect between Numpy and Pandas in such a way that the values that you store in a Pandas series are represented as Numpy array. Okay, so therefore you can get the shape, you can get the size, and so on and so forth. So let me share this one with you. Unless you have a question, then we can just proceed to the next part. So I've shared that one with you so you can try them out. So those are, I've actually now printed the properties I think I should have copied everything here. The properties of Pandas series. Okay. So now from there, I wish to proceed. So these are the key features of a series. They act like a dictionary in such a way that this indexing Monday, Tuesday, and so on represents the label. So these are the key. Let me show you that one. Let me show you that feature here. Let me copy this one here. Okay. Copy that one. And then I paste it here. So we're being told that around this one, this key, this indexing, these labels, they act like a dictionary. If I want to get the first item and 180, I just have to go to my stock prices and access. So I don't think it's Monday. Just confirm. Okay, I think this one will be demonstrating it later. Just remove it. But we can actually see that one property of a Pandas series is that they act like a dictionary in such a way that the index are actually the labels. The index are actually the labels. You can see that they can hold either numerical data or textual data. So you can actually put numerical data here or textual data here, and they're very fast and efficient. So for example, some of the common operations you can perform. So let's try common operations. Common operations on Pandas series. So common operation include a good example. They are trying to see what is the maximum stock prices. What is the maximum stock prices? Stock price. So if I run this one, if I print here, the maximum stock prices is 220. I hope you can see. So out of all these Pandas series, the maximum value is 220. You can definitely get one by actually accessing the series. Remember, we said that the stock prices are represented as a Numpy array. And yesterday we saw that with Numpy array, we can do mathematical operation like maximum. So the maximum stock price is 220. The minimum is 180, confirm. The minimum is 180. The mean is 179. The median is 199, 195. So these are some of the common operations that you can apply to a Pandas series. And you're going to see they'll be very, very helpful in our subsequent classes. Okay, so the minimum, so we can even perform filtering. So this one number one, mathematics. This one statistical operations. Statistical operation. We can also perform filtering operation. Number two, filtering operations whenever we want to extract information from the array, from the series. So a good example is I want to get days when the stocks were above 190. So this is now I want to get an insight in such a way that I want to find the days when the stock prices were above 190. So for you to get this information, for you to extract this information, you can actually say that I want to, let me just make it simple. So you go to your stock prices, and then you filter the array. So you want to filter the array. And then after filtering the array, you want to get now the stock prices. Sorry. The stock prices that was above, so greater than 190. So this is a Boolean operation. You only return prices that were above 190. So if you run this one here, then you are told that on Thursday, Friday, Saturday, and Sunday, we have filtered them in such a way that now the stock prices are above 190. So this is actually how you filter information from a Pandas series. Just put a condition here. So I want to extract a condition in such a way that I only want to pick when the stock prices were above 190. And you're getting this output here. So on Thursday, Friday, Saturday and Sunday, the stock prices were above 190. So moving further, you want to calculate the average stock price. This we have already done this one. You can also apply some mathematical operation. For example, I want to increase. So I want to adjust my prices. So B, just showing some demonstration. So I want to adjust my prices by 5%. So I want to increase my stock prices by 5%. So I want to increase my stock prices by 5%. So I think maybe I should cut this one. Test it here. Then I want to apply. So this is when we are now trying to apply mathematical operation. So this is something we are going to do later as we are doing some more analysis. For example, I want to increase the prices by 5%. So 5% is 1.05. So if you now print the adjusted prices, then now we've now increased the prices by 5%. So we've adjusted the prices by 5%. So if you are selling at 180, now we have adjusted them to 189 on Monday, Tuesday. So all the prices have been increased by 5%. If you wanted 10%, then it should have been 10%. So now I've increased the prices by 10%. So these are some of the operations that you can do to a Pandas series. And we are going to do them later in more advanced analysis. So here we're just doing some preparation so that now we are now ready to perform analysis using Pandas. So this is when you want to filter information. This is when you want to perform some mathematical operations to a Pandas series. So I'm also sharing that one with you so that we can also try them out. So in real world scenario, as we now finalize on Pandas series, we can say that we can use Pandas series maybe when you want to perform market analysis. Let's say you want to track the stock trends, or let's say you want to make an investment decision. That is something you're going to see later using a Pandas series. So a quick recap to say is that a Pandas series, it's just an information that is represented in a single column. So this is a single column here. So this single column here, we have the name of that column. We have the index for that column. We have the values for the column, and we also have their data type. That is basically what we call a Pandas series. So just something to remember is that a Pandas series have 4 properties. So we have the name, Here we have the values, and I've demonstrated that these values are represented in a Numpy array. We have the indexing, which can be customized, and we have the data type. Any question up to there to do with now Pandas series? Any question up to there with Pandas series? Before now we move to data frames. Any question up to there with Pandas series? Okay, so I can see we are good. So let's now try to differentiate now between a Pandas series and a Pandas data frame. And this is now where the beauty will start. So a data frame is a table for structured data. So let's go there and now talk about a data frame. So at the code cell here, talk about Pandas data frame. So we are saying that with a Pandas data frame, it's basically table. It's something like a table for representing structured. So it's a table for representing structured data. So this table, we are saying it's a table because it is made of rows and columns. So definitely we can say that a Pandas data frame is a two-dimension data. So we have the rows and we have the columns. So it's a 2D. So these are 2D data. So we can even say two-dimension data. For the series, I can even refer to it as a one-dimension data, a single column data. So 1D, one dimension. So then the data frame is definitely a two-dimension data. So I will differentiate this one in a short while. But let's see what now the notes has to say. But so we're being told that a Pandas data frame, it's a two-dimension table, something like an Excel sheet, where we can store multiple columns. That's why I was calling it a multi-column data structure. Multiple columns of data, where each column, this is very important to note, we can store multiple columns of data where each column is a series. Because we say that a series is a single column data. So if you combine several columns, now we form a Pandas data frame. So for example, I can give you an example. I wanted to record employee data. So employee salary data is actually having multiple records. So to do this one, you will definitely start from a dictionary. So you're being told that it is made of multiple column data where each column represents a Pandas series. So that is what I mean. So let me give you an example. I want to record employee salary data. So to do this one, I will start from a dictionary. And I want us to begin here. This is actually a dictionary. And remember, we said that with dictionary, data is represented in terms of keys and values. So in dictionaries, data is represented in form of keys and values. So let me just demonstrate here. For you to represent employee salary data, we have the employee names. And then we put the list of all the names for the employees. So this is actually a series. So the series, the first column is the name for the employee, where the name is the key. and the values for the employee names, comma. Don't forget this comma. This is a dictionary. We go to the next part. The age is represented with the list of all the ages for this employee. So this is another series. We have another column to represent the age. Don't forget the comma. So we also have another column to represent their job role. I hope you can see this is the key, their job role. The values are the following here, the roles of each employee. And then finally, we have their salary. And we have a list of the salary for all these employees. So if you can actually see that in this dictionary, we have multiple columns. So I have a column to represent the name. So this is the first series. I have another to represent the age, another series to represent the job role, and the last series to represent their salary. So if I combine these multiple series that you've been learning, we now form a data frame. So how do you create a data frame? So to create a data frame, then you just have to, I don't want to print, just want to copy this one. I want us to be very keen here because now this is all starting the analysis. So you can actually say that, let me just call it, okay, the data frame is using Pandas. I will call the data frame class. So remember, the data frame has to start with capital D, then capital F, data frame. Then you put the dictionary right here. So if you have a dictionary that is placed here, and then definitely you should be getting a data frame. So let me run this one and see whether, so I hope you can see that this is something like an Excel where we have the rows. So these are the rows and these are the columns. So it's actually a two-dimension data where we have rows, where each row represents a record and each column represents a field. So you have the field to store the name, another field to store the age, to store the job role, to store the salary. I want to try this one and let me know in case you get an issue. I want you to try this one here. And this is actually now the data structure that we'll be using all along for our analysis. So this will be the data structure that we'll be using all along for our analysis. So we'll be mostly using a data frame. So to actually connect the dots, a data frame is made up of multiple series. The first series for the name, the other series for the age, the other series for the role, the other series for the salary. And you can see that by default, each series here can be indexed by default, we say this is 0. Okay? By default, we say the series can be accessed by indexing starting from 0. And then we have their name, like that one. So this is what we call a data frame. So each value, it's a Numpy array. For example, if these are the names, the list of all these names here, it's a Numpy array. So starting from the name, we have a Numpy array to store the name. Going to the age, we have a Numpy array to represent the age. Similar to, with the job role, this is actually an array that we have used to store each specific role for the employee, and similar to the salary. I hope you can see one common feature about Numpy arrays that they can only store data of the same data type. So if you have the names, then you cannot have a number here. This entry should only represent the names. If you go to the age, they only represent numbers. If you go to the job role, they only represent text that we'll be calling them objects later. And the salary, we have integers. So these are Numpy arrays. Each Numpy array is represented in a series. This one series, another series, another one, and another one here. And then if you combine multiple Pandas series, we get now a data frame. So any question up to there? connecting between now and Numpy array, a Pandas series, and a Pandas data frame. Okay, so if no question is still there, I think we can proceed. So we've been told this is the output. So it's actually the now data frame where we present data in a table format. Okay. So before doing this common operation and going to the advanced real-world examples, we can definitely talk about properties of a data frame. Properties of a data frame. So let's go here. Properties of a data frame. Properties of a data frame. The first property definitely should be the shape. The shape. And I think which actually a data frame will actually capture the properties we add in a Numpy array. So we also have the size. We also have the size. So we have the shape. Yes, I think that's a very good observation, how we can import a data frame from a different source. I think I'm going to do that one in a short while. And before moving on, so we have the shape, we have the size. Yeah, so I think those are the two major properties. And also we have the info, but I think info is a method, so we're going to do that one later. So the shape talks about the number of rows and columns, the number of rows and columns in your data frame, and the size. Okay, I think maybe we should just have to print them. So we can actually say df.shape. Let's see the shape. So if you print the shape, it's actually specifying that we have 4 rows, 1, 2, 3, 4, and 4 columns. So the column for the name, age, role, and salary. So we can say that the shape is used to represent the number of rows and columns. Less about the size, by the size. By the size. So the size will actually refer to the total number of records. I'm sure what this one means. The total number of items in the array. So the size will actually be the total items stored in the array. So for this one, this here we're being told we have 16 entries. So shape and size. So if you run this one, so these are the two properties of an Numpy array. I can copy this one and share it with you here. And before we even go to operation, like we've seen, a very good question from let's confirm the name. I can't get the name, but just a minute. There's a very nice question from one of us here. I can't get the name, but I think he has asked us a very, Martin Onyango. So you're asking whether can we see how to import data frame from different sources before we move on here? That's a good observation. So importing data frames. So importing data frames. I've actually forgotten about this one. From different sources. Importing data frames from different sources. So to do this one, I think, okay, it's okay. Yeah, I think it's okay. So I have a link here. Let me share this link with you. I have a certain link here. Not this one, but this one here. I have a link here. Let me share with you the URL. Okay. And first give it this URL. I think I can try it first. Try it first here. Then we can explain. I've not defined the column, sorry. So yes, this is what you're asking. Can we read information? Okay, move the head here. So if you want to read information from different sources, so to read information, data from different sources, as we'll be doing in our next class. This is something that we will be doing in our next class from different sources, just to have an overview from different sources. We can use the following function. We can use the following functions. We can use the following functions depending on the data. So we can use the following function depending on the data. So for example, if you are to read an Excel data, so if you are to read an Excel data, then you're going to use pandas dot read, then you put underscore Excel. But we'll be doing this one tomorrow in more details. You can actually go with read Excel. Then you put the link to your Excel data. It could be hosted on the, or you could be having it in your project. So number two, you might also want to read. Is there any question? Is it a question? Yeah, DF represents data frame. You can represent data frame. Represents the data frame. I think now we're ready to proceed. So I was talking about, Martin, you've asked a very good question. How do you read information from different sources? So this is something we're going to do tomorrow, but just to demonstrate is that if you want to read information that is in form of an Excel, then you can work with the read Excel. If you're doing, there's other information stored in CSV files, then you can also work with pandas dot read underscore CSV. Then here you pass the link to your CSV data. Then moving further, you also have JSON. You also have JSON, number 3. You also have JSON. So if you want to read information in form of JSON, then you can also have pd dot read JSON. Then you pass the link to your JSON data, and so on and so forth. I think we have HTML, we have text, but these 3 are the most common ones. So for example, the information we are reading here was actually from the internet, and it has been stored as CSV data, So because I'm not sure which kind of information I'm getting, I think these are the others. I can just call it data frame, but in other words, you can even call it data, and just call it data so that I don't confuse. You can even call it data. It's just a variable that we store the information you are reading. So as you read this information, if you want to see the information, you can actually view them here, data. And then if you run this one, you're getting the information here. I hope you can see. So this is an information we have read from the internet. So at some point, as you read information, you're going to see that it comes with some inconsistencies. So you need to do some data cleaning. So a good example of a data cleaning that was done here, the project I was doing here, you can actually modify the column names. So these are the column names. These are the column names. You can actually put them here. So these are the column names. These are the column names. And now I can say that after reading the URL, the names of the columns are actually in the variable called columns. So if I now run this one again, I'm now going to read a very nice information from the internet. So I hope I've answered you, but definitely this is something now that you're going to learn starting from tomorrow. So for today, I wanted first to focus on pandas and series and data frames. And now tomorrow we are now able to work with several information, even from different sources. So let me share this one with you. Just for Martin, that you had asked that very nice question. I hope I've answered that one. I hope I've answered that one. So now moving further. Yeah, so Koda, you're asking, what if the data set is from the computer files, not online? So what you're going to do, reading information, we'll be doing them tomorrow. We'll be doing them tomorrow in such a way that you can actually store the data here. We see that one tomorrow. You can store the data here. I don't know if I have any data set. I don't have any for now. But normally we upload the information here. So you can just upload it here using this command. You upload your data set. I don't know if I have an Excel data. But these are confidential one. Let's see if I have any that is making sense. But I think we are going to do that one definitely tomorrow. Let's do that one tomorrow, such a way that you can upload your data here and read it offline, to your project. Okay? And read it. So long as you provide the link here, so this link could be from online or from offline, and then definitely you'll be having your record here. So let's proceed with Pandas data frame. Let's proceed with Pandas data frame. So what are some of the common operations you can do to a Pandas data frame? So I want to copy this one here so that we have some common operation in a Pandas data frame. So common operations in Pandas data frame. Pandas data frame. So these are the common operations. So for me to do this one, I will first want you to copy the above one. I want you to copy this one here. Make sure you copy this one here. And then you put it here. Just put it here. So if you have this data frame, I want you to imagine this is a record you've actually read from a school database or from an hospital system. What operation can you do to this kind of data? So the first one here, so let's have a code cell here, is you are allowed to sort them. You are allowed to sort them. So we can sort employees by salary. For example, I want to get employees starting from the highest paid employee to the lowest paid employee. So you can sort employee by salary. So to do this one, we will be using a function called sort values. So we can actually say that in our data frame, I want to sort values. So sort values is a function that is provided by Pandas dataframe. And then as I'm sorting these values, I want to sort them by employee's salary. Okay. So if you run this one, by default, it will sort them in ascending order. So by default, it will be sorting them in ascending order. This is ascending order. Ascending order is from the lowest paid employee to the highest paid employee. Or you can even sort them by their age. From the youngest employee to the lowest employee. I hope you can see from the youngest employee to the lowest employee. Let's go with the salary. Now the question is, how about if you want to sort them from the highest paid employee to the lowest paid employee? Then you can actually add a parameter here. Sorry. You can add a parameter here, call it ascending is false. This is one operation you can apply to a data frame. You can sort the records in this manner. Now we've actually inverted in such a way that the highest paid employee was Charlie, followed by Alice, followed by David, and now we have Bob as the lowest paid employee. So we have sorting operations to data frames. I want to share this one with you. We can sort them. Sort them. We can sort them here. So we're able to sort this information. Alternatively, we can also filter records. We can also filter records. So to filter record means you want to get specific information. For example, just you want to filter employees, the salaries that is above 40,000. So to do this one, you just have to get your data frame. So, sorry, I've not shown you how to pick a column. So if you want to pick a column, I think I should have shown you this one. If you want to pick a column, let's say I want to pick the column salary, I can just pass the salary as the key, like this one here. But this is something we'll be doing more details tomorrow. So if you run this one, then you get the values for the salary. So you get a series. So this is a salary. If you want to pick the job role, then you can just say job role here. So if you run this one here, you get all the job roles in a Pandas series. Similarly, if you want to get the age, you just need to put the name of the column here as the key. You just need to get the name of the column as the key. Then it will give you the values in a series, Pandas series. This one here. Okay? So this is actually how you pick columns. So for example, you are told to pick those people who are paid above 40. So 40,000. So for us to do this one, we first have to pick all the employee salaries. All the employee salaries. And you want to see those who are paid above 40,000, like that one. I only want to filter record where the salary is above 40,000. So if you run this one, then it will return some Boolean. At this point, that was true, and this was true. So for me to get now this record, I'll just have to take my data frame, take my data frame, and pass this condition here. Let me pass this condition here so I can copy this condition and pass it inside my data frame like that one. So if I run this one, then I'm getting that I only have 2 employees who are paid more than 40,000. I have Alice and Charlie. And I can even go ahead and even sort the values, something we'll be doing later, in a descending order. So I don't want to confuse you much, but now you can even sort them out. But for now, if you want to filter records, you just need a condition. And this is actually how we actually run a condition in such a way that you pick a column, and then you pass a condition. I only want salaries that's above 40,000. I hope you can see that it was returning true, false. So we say that in a condition, we normally return true and false. So if this is a condition, we can use it to filter in our data frame, such a way that this was my data frame. This is my entire data frame. This is my entire data frame. So for me, inside this data frame, I only want to pass this condition. I can take this condition and pass it here. So it will only return for me all the salaries that are above 40,000. So this is what we'll be doing in our filtering operation. So this is B. So we'll be doing them in more details later. I can copy this one. I can also share them with you here. That one. So this is actually how we do filtering. In case you have a question, don't forget to ask. So moving further, we also have more operation to be done. Let's say you want to calculate the average salary. Average salary. So what is the average salary? What is the average salary? So what's the average salary? It was B. What about if I want to say, I want to calculate, sorry, I copied. Average salary. Yes, average salary. I want to get the average salaries for all these employees here. So for me to do this one, I'll just have to pick that column, salary. So I'll say this is how we pick a column, salary. This is how you pick a column. So these are all the salaries you have. These are all the salaries you have. So if you want to get the mean salary, you just have to call the Numpy function called mean. And then definitely you should be getting that the mean salary is around 47,500. So this was the mean salary. So you can even do the minimum salary. The minimum salary. The minimum salary was 30,000 and perform the maximum salary. Maximum salary was around 70,000. So you can actually apply all the methods that we did on Numpy arrays. So the mean salary was that one. And then finally, you also have, can you add a new column? Can you add a new column where we want to add a bonus 10% of the salary? So you can also add a new column, adding a new column. And for this column, we want to add a new column with the bonus salary. So to do this one, to add a new column, remember in a dictionary, you just need to add a new key. So you can say in my data frame, I want to add a new column called bonus. That one. And this bonus will be, I want to take each salary. I want to take each salary and then I add 10%. So to add 10% is to multiply by 0.0.1. So that is 10%. So if I now print the entire data frame, I can even add a new column. And this actually now I have a new column. I think it has not added it. Let's see why. Let me say. We'll be adding, sorry. It's not added. I don't know why it's not adding. Let me see. I think it's adding to, let's just go with 20%. So thereby you can add a new column. So for you to add a new column, you just need to provide your new key. So to your data frame, you add a new key and then you apply the operation that will actually provide all the values. So definitely this is something we'll be doing in our more subsequent classes. I just wanted to give some demonstration of how powerful this Numpy library is and how we are going to use it in our data analysis classes. So for me to even do this such kind of demonstration, I didn't provided these real-world examples. I provided these real-world examples. Whereby I wanted to show how you can even do climate change data analysis. Climate change analysis, sorry for that one. Climate change analysis, for example, you can have climate data. So let me even try this one as you now wind up. More advanced analysis. For example, you can be provided with climate data, or you can even go and read climate data, like this one here, whereby we have the year and the average temperature. So for every year, for each year, we are recording the average temperature in the Earth. So what kind of analysis can we do with this kind of data? So I'll share some few insights. Probably you can get the trend. You can get the trend. So let me try to see the trend by actually doing the difference. So you can actually get the trend in such a way that, sorry, we can even calculate the temperature trend by actually taking the average temperature and getting their difference. So if you run this one here, we can see that I shouldn't have printed. I don't want to print. I don't want to print. So you can see that this is actually the trend. This is actually the trend. So the first one, we didn't have a trend because it's the first one. But now from 14.3 to 14.5, we had a trend of 0.2, 0.3, 0.4, 0.5. So this is actually the trend, okay? And you can even plot it. You can even say climate data dot plot. I don't know whether it will give us a graph. Let's just say. So this is a trend, but I think we'll be doing this one later. It's not making sense. So if you have the climate change data, you can actually get a trend of how the temperature is rising. And this is something you can demonstrate to people. So this is one area, just to demo. That is the first one. I'm sharing that one here so that you can also try out. I had also provided you another one. So this is actually showing us that there is a steady increase in global temperatures over here. Using the difference function, it calculates the change in temperatures between years, highlighting how climate change is accelerating. So this analysis can help policymakers and environmentalists make decisions on climate change, climate action strategies. So let's say you're provided with sales data. You're provided with sales data. Provided with sales data here. Say you have, I can first comment these lines. You have been provided with sales data. So if you run this sales data, this is what you get. Maybe they provided you with this product they are selling, the sales they made, and the revenue they generated from that sales. So then you're told to do some analysis. Probably you can do an analysis to get the most profitable product. So if you run this code here, you're seeing that, I don't want to print. the most profitable product for this retail store was phone, because they had a revenue of 900,000. So you just wanted to get the maximum revenue. And you can even say that the max function can help us determine which product generates the highest value. This insight can allow businesses to prioritize high revenue products for marketing and inventory management. So you can also do the same for low performing products so that you may need discounts or promotions. So if you're going to healthcare, I was just giving you an overview of where you can be applying these skills. So let's say you're provided with health records data in such a way that you're given hospitals, you're given patients, and you're given doctors. So you have 150 patients being attended by 20 doctors, 30 doctors attending 200 patients, 25 doctors, 170, 35 doctors, 220. For these four hospitals, A, B, C, and D. So then you might want to calculate the doctor to patient ratio by actually dividing the number of patients with the number of doctors. And you're seeing that now, just do it in a data frame. This is the doctor-patient ratio, such a way that in hospital A, the ratio is 7.5. So the ratio is very high. Compared to B, 6.6, C, 6.8, D, 6.2. Where can you use this kind of analysis? You can use it to help hospital evaluate their staff allocation. So the high ratio may indicate that doctors are being overworked, leading to potential care issues. So this analysis can help health administrator optimize their staffing levels. Okay, if you do education, let's say you want to do some education analysis, I can just share this one because of time. It's almost 11. You can see that we have different schools. So we have school X, Y, Z, and W. This school have 500 students, 750, 600, 800. We have 40 teachers in school X, 50 teachers in school Y, 45 Z, 5 W. So which kind of analysis can you do here? So a good example is we can actually calculate the student to teacher ratio. And we're being told that this is actually the student to teacher ratio. And where we can apply this analysis is to indicate overcrowded classrooms to help educational planners determine where to hire more teachers. So the low ratio often results to better performance due to increased teacher attention. I even have one, there are so many areas you can apply these kinds of skills. Let's say you're doing transports and logistics. Probably you're seeing that we have different cities. Let's say you have London, this way. So you want to see which city have the shortest commute time. So let's say you want to settle a business in a certain city and you wanted a city that have the shortest commute time. So you definitely prefer Tokyo. So this analysis can be used. So the city with the shortest commute time can serve as the benchmark for efficiency. So high public transport usage is often linked to reduced traffic congestion and lower carbon emission. Therefore, city planners can use this data to improve on their public transport policies and investment infrastructure. So in conclusion, we can say that today we've learned about Pandas as an essential tool for data-driven decision-making across several industries. Okay? Therefore, by using Pandas, we're going to see that in our next classes, without reading data, we can use it to help businesses optimize their sales strategies. We can use Pandas to help hospitals allocate resources efficiently. We can also help schools improve teacher-student ratio, government to plan for their better transport system, and